So you see that in every problem, the whole problem is done into breaking into pieces and connected into things that you know. Probably you didn't know this, but it's like, okay, after 2 months, you will get to know this anyway, right? But at least you must get to the point that you know, right? And the rest of the things you are learning already from Cheenta. So that's why you get connected and learn the required knowledge that you need to have, and till what you have got, that will build the breach. But at least you should try out this. I have not done anything here that cannot be done by an 11, 12 children, right?
Hello, guys. Welcome to Cheenta's School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics.
So here asks that if a1 is equal to 1 and a is equal to this, then what is the limit of this? Now, when I look at this problem, what things first comes to my mind? Rather, what thing should come to your mind? As I've told you, your goal should be to break down the problem into simpler pieces. By simpler pieces means, by simplicity, it means that you have seen the problem before, or you have tackled a similar kind of problem before. So essentially, you're mapping a new problem back to your old knowledge, and I have talked about it in the previous videos too. So the first natural thing that it seems is we have to, this is a complex part, right? This is a complex expression, the pn. So the next natural question is that can we simplify this pn? Because if it was an easy expression, we could have done it easily. But here we are trying to understand what is the limit of this pn. So therefore, the first possible thing is to simplify this pn, because we want to map it back to the original things. Now, based on what? Based on what information? So we have this pn, and we have two additional informations, the a1 and the relationship between a1 and an minus 1, right? So we want to use this and the expression of pn to boil down into a simpler thing. So let's do that. That's exactly what I mean. So you have some given information and you have a complex problem or complex expression. Sometimes this complex problem is built up, another complex problem is built up of this simple complex problems. So you have to understand each of these problems in details, okay? These ideas in details. So here is Pn. And so let's try to simplify it using the information of an and a1. So we have an is equal to n into n minus 1 plus 1. So what will we do? So can we find out this kind of expressions out from there? Rather, can we simplify this? If you simplify this, you will get a1 plus 1 into a1 into a2 plus 1 by a2 dot 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 into an plus 1 by an. And you can see that yes, something here is similar here. You can easily see that. And you can see that, oh, nice. So a1 plus 1 is nothing but a2 by 2. So an minus 1 is plus 1 is nothing but an by n, right? So what you do is that you try to use the information, because this is a one-to-one information. Replacing this in this is means that you're using that information out in the problem, okay? So let's use that. So you put a1 plus 1 is equal to a2 by 2, and similarly for all of them. So you get that first one a2 by 2 times a1, and the next one will be a3 by 3 times a2 dot 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 an by n times an minus 1 times an plus 1 by an plus 1 times an. So let's write it in a very simple way. So you have that. So that's why algebra is made, because algebra makes things simpler, less variables to handle, okay? So let's write it algebraically. So we have this equation, right? We have this equation, right? Now we know that ai plus 1 is nothing but ai plus 1 by I plus 1, right? So we will replace it here. ai plus 1 by I plus 1 times ai. So if you observe, therefore, that there are two. So now you break this problem down into two problems. So you have these two simple things. One is without a and one is with a. Because why you did this? Because you know this is a simple, this is one interesting value, because it's product of the i's, and you know it's something related to n factorial. So essentially, whenever you observe, you again, why you did this step? Because you want to map it back to something you know. that is n factorial comes up here. So this is nothing but n plus 1 factorial, right? 1 by n plus 1 factorial. And now you're left with this. Now this thing is an interesting thing. So if you write it down, this is called a telescopic product. So if you write it down, it's a2 by a1 times a3 by a2 times a4 by. So you are simplifying things into algebra to arithmetic now, so that you can understand the pattern and then again put it back. So you see, every step is nothing but breaking down a problem, solving the problem, putting it back together, and it's nothing but doing this over and over and over again. Okay, that's it. I hope all of you are getting this idea, what I'm trying to share to you. Try to implement his strategy into solving the problem so that you can replicate this in your own problem solving. A5 dot 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 an plus 1 by an. So if you observe a2 get cancelled, a3 a3 get cancelled, a4 get cancelled, dot 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 till an gets cancelled. So we are left with nothing but an plus 1 by a1, and that simplifies the problem. So we have that, therefore Pn is nothing but n plus 1. Now a1 is equal to 1, so a1 is equal to 1 by n plus 1 factorial. All of you understood this, guys? Yes or no? We have realized that Pn is nothing but n plus 1 by n plus 1 factorial, and you have to find its limit. So this boils down to a new problem, that how can we find the limit of an? You see that the finding the limit of an Pn is equivalent to finding the limit of, is turning out to be finding the limit of an plus 1 by n plus 1 factorial. So you have to know how to find the limit of an, and that's the interesting part. So now to find the limit of an, or rather an plus 1 by n plus 1 factorial, you have to understand one certain thing. You have to understand that we have this only one information. So therefore, from this one information, we have to find the information of this. So let's go to our next new page. So we are given that an plus 1 by n plus 1 factorial. This is the limit you want to find, and you're given this relationship that an by n, rather an is equal to n times an minus 1 plus 1. This is a relationship, and you want to use this relationship to get the limit of this. So to do this, therefore, somehow using this relationship, we have to get this expression, right? Somehow get this expression. Otherwise, we cannot operate with it, right? You have to get that expression in hand from this relationship. This is not an is equal to some algebraic expression. This is a relationship between an and an minus 1. So to get this limit, we have to get this expression out of this only given relationship, right? Between an and an minus 1. So now we are trying to use this expression to get this expression. Understand this very carefully. So we have an is equal to n times an minus 1 plus 1. So we want to get this expression. So so here for Pn minus 1, it will be an by n factorial, right? So therefore we want to have n factorial on left hand side. So let's have n factorial on left hand side. So this means we want to have this, and therefore we have that an by n factorial is nothing but, it's interesting, n minus 1 by n minus 1 factorial plus 1 by n minus 1 factorial. This is interesting because you have that Pn, this is Pn minus 1, sorry, this is Pn minus 1 is nothing but Pn minus 2 plus 1 by n minus 1 factorial. All of you understood this? So we want to get this expression. So we got that we divided it by both sides to get this expression, Pn minus 1 and Pn minus 2. Now this is interesting. We have got this expression out there. Rahul, did you understand? Okay. Now this is interesting because if you write this down, you have, so it's Pn starts from, n equal to 1, right? So it starts from n equal to 1. So we have that P1 is equal to, so P2, so therefore n minus, because this is n minus 2, right? So you can write that Pn minus n plus 1 is equal to Pn, because it's less, plus n plus 1 factorial. Okay. So this leads to the fact that, so let's write it down, because n starts from 1. So P2 is equal to P1 plus 1 by 2 factorial. P3 is equal to P2 plus 1 by 3 factorial. Dot, dot, dot. You want to have Pn, and therefore you write it with respect to Pn. Pn plus 1 is equal to Pn plus 1 by n1. Let's do it till Pn. Pn is equal to Pn minus 1 plus 1 by n factorial. So if you observe this very carefully, you will see that if you add this up again, you will see that this 2 gets cancelled, because this will be equal to, if you add this up on the left hand side, this 3 2, all of this get cancelled. So you will be left it. This is called arithmetic sequence, because this is an arithmetic progression, right? Because each term is increasing by a similar to arithmetic progression. Arithmetic progression, it increases by single quantity, but here it increases by a variable quantity every single time. Everything gets added. You can see every time a new number gets added. So you can find the general number, and this is the way to find the general number. You add it. On left hand side only Pn is left, on the right hand side P1 is left, and what you are left with a summation from k from 2 to n, 1 by k factorial, right? And P1 is nothing but what? If you remember P1 is nothing but 2, right? Because it's 1 plus 1 by a1. So therefore you can see that it's 2. So you can write it 1 plus k is equal to n2, 1 by, because I just added 1 factorial here. And even more than that, you can make it k is 0, because k factorial 0 factorial is 0. So this. Now you know that this is nothing but, do you know what this is? Now this implies that limit n tends to infinity, Pn is therefore limit n tends to infinity, summation k from 0 to n, 1 by k factorial. Now this is a very interesting expression, and that's why the Taylor series comes in. And this is the expression of, anyone knows it? It's an interesting Taylor series expansion. It's E. So even if you have got till this point of time, it's okay. But later as you move ahead, this is restricted, called T.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.